The binomial distribution. And this is where we're going to start using Megastat in the course. So it's very important that you know how to do this because we'll be using this add-in for the rest of the course. Okay, the characteristics of binomial, and you are expected to know these. A binomial experiment will always have a fixed number of trials. It won't go on endlessly. Each trial will only have 2 outcomes, but the interesting thing is we usually can reduce most experiments to a binomial. For example, let's say that I survey my classes on where they went for aid. That could be reduced to a binomial because I could make one outcome very specific and the other outcome kind of everything else. So for example, I'm surveying the class about where they went for Eid, and my 2 outcomes are they went to Thailand or they didn't go to Thailand. So we could do that as a binomial experiment. So as I said, most experiments can be reduced down to a binomial. Okay, the outcomes of each trial have to be independent of each other. That means that if Abdurrahman went to Thailand, it's not going to affect the chance that Omar went to Thailand. Okay, and you should already know this idea of independence from previous lessons. And the last characteristic is that the probability of success has to remain the same for each trial. Okay, and as usual, it's easier to understand this if we just look at an example. So here's our example. 5% of DMC students are afraid of being alone in a house at night. We're going to select a random sample of 20 DMC students. And then we have these probabilities that we want to find. Okay? Now, this is the point. If you're watching this, you really should pause this and you should open Megastat. Okay? The way to open Megastat, you should have it on your desktop. If you don't, go to BB Learn, Business 2203, go to weeks 4 or 5, and Megastat is there for you. Okay, for every single class I teach, you all have it. You need to save it on your desktop. Okay, so I'm going to open this, and then from now on, this is how you're going to open Excel. You're no longer going to open it from the shortcut at the bottom. Okay, for statistics, from now on, you're going to have this file on your desktop. You're going to double click on it. You're going to open the one with the little Excel icon next to it. Okay, you will get this scary message. Just ignore it and click Enable Macros. Okay, then some students, when they get to this point, say, oh, miss, it doesn't work. Duh, yes, it does. You just have to open a file. So File, New, Blank Workbook. Okay, and you'll see that there's this new tab called Add-ins up here at the top. Okay. So if you click on it, you'll see Megastat here. Let's go back and look at our problem. Okay? For every binomial problem, the 2 bits of information that you have to pull out is you have to pull out the probability and the number of trials. Okay? So in this example that we're doing, here's our probability. Okay, 5%. 5% of the students are afraid. Okay, and how many students did we sample? Well, we sampled 20, so that's our number of trials. Okay, so our probability is 5%, our number of trials is 20. So I'm going to go back to Megastat. Okay, Megastat, I'm going to scroll down to probability. Okay, we're doing discrete probability distributions. I'm going to click on that. And here it opens up this window for me. We're doing the binomial. Okay, and I just told you guys the 2 bits of information you need to know, number of trials and probability. And in the example on the PowerPoint, the number of trials, well, we surveyed 20 students, and 5% of the population as a whole is afraid of being alone in a house. Now, one of the many nice things about Megastat is you can just put in percent. Okay, no need to change it to a decimal. So those of you who might be a bit weak at that, and judging from past classes, there are a fair number, you can just put it in as a decimal. Okay? So you put in your number of trials, you put in the probability of occurrence, and then you click OK. And the magic of Excel, oh wow. Okay, Excel has done all this wonderful work for you. Now, Of course, you have to know how to interpret it. Okay, it doesn't mean anything unless you know how to interpret it. So let's go back again and look at what we were supposed to find. Well, we're supposed to find the probability there are exactly 5, at most 3, at least 3. So I'm just going to write those here. So we're supposed to find the probability exactly 5 are scared. Okay, probability at most 3 are scared, and the probability at least 3 are scared. Okay, yep. All right. I always like to put my borders in because I'm kind of OCD. Okay, guys, look. Megastat gives you, when you run the binomial in Megastat, it's going to give you 3 columns of information. The first column gives the x values. And as I told you when we started this class, okay, well, as soon as we started doing probability distributions, I told you you always have to know what x represents. Okay, so x represents the number of people who are scared, right? Then we have this column, okay, which I call the individual probability column, the P of x column, okay? And that just gives us the probability that x will equal these individual numbers. So, for example, the probability that exactly 2 people are scared is 0.18868. All right, now one of our questions was, what's the probability exactly 5 are scared? So, x equals 5, the individual probability, so the probability that exactly 5 are scared, well, there it is, 0.00224, okay? I could have just copied it, 0.00224. Okay, so if you have an exactly question, you use the individual column. All right, I'll try to make this color-coded. Okay, so exactly, you're always going to use the individual column for that. Okay? On to the next question. The probability at most 3 are scared. Now here's where we have to use the cumulative column. Okay, the word cumulative means like running total, like adding everything up to that point. So, for example, this number here, okay, the way Excel calculated this number is it just added all of these numbers. Okay? These 4 numbers, the sum equals 0.98410. And if you don't believe me, you can check it on a calculator. Okay? So, this number here is just the sum of the probability of 0, 1, 2, 3, 4, 5, and 6. All right? So, if we want the probability that at most 3 are scared, okay, that means let's put this into our probability language from earlier units. Okay? That was not what I wanted to do. Okay, the probability at most 3 are scared. That means the probability that 0 or 1 or 2 or 3 are scared. Okay, you can remember from previous lessons that in probability, or means plus. Okay, so I hope that you can see how we're going to do it. The probability at most 3, well, it's going to be the sum of the probability of 0, 1, 2, 3. Now, wonderful Excel has already done that work for us because the probability of 0 or 1 or 2 or 3, you know, it's already summed them here, the cumulative. Okay? So that will be the answer. Okay? So I can just copy that and paste it here. So the probability at most 3 are scared is 0.98410, which is the sum of those individual probabilities. All right, the last example, the probability at least 3 are scared. Okay? Now what that means, and I think I'm going to get rid of the colors now. The probability that at least 3 are scared means that the smallest number that are scared is going to be 3. So it could be 3 or 4 or 5 or 6 or 7 or 8 or 9 and on and on and on and on up until the end. Okay, again, your knowledge of basic probability. Or means plus. Okay, so the probability at least 3 are scared is going to be the sum of these probabilities, isn't it? Okay, 3 or 4 or 5 or means plus, so we can sum all of these. Now, there are 2 ways that you can do this. Okay, there's one way that I think is very logical, but some students prefer to do it a different way. I'll do it my way first. Okay, guys, when it's an at least problem, basically the formula for that is you're going to take 1 minus the probability of the number before, the cumulative probability. Okay, so let me just go ahead and do that. I'm going to hit equals 1 minus, and I'm going to hit the cumulative probability for the number that's small, 1 less than what the problem gave me. So I'm going to take 1 minus the cumulative of 2, and there it is. All right? Because guys, we learned in a previous lesson that a probability distribution, the individual probabilities always sum to 1. So one way of getting the sum of all these probabilities that I've highlighted in this ugly peach color is we can just delete, we can subtract out the ones that we don't want. Okay? Now, some students prefer to do it a different way. They prefer to just sum these, which you certainly can do. And I urge you to do it in Excel, because the earlier you become comfortable with Excel, the easier your life is going to be in my class. So we can just hit equals, SU, okay, a quick double click on the sum function, and then just highlight these numbers that we want it to sum. And you can see that we get the same answer. So it doesn't matter which way you do it. Okay, you can do it either way. You can either do it 1 minus the cumulative of number before, okay, or you can just sum the probabilities. Probabilities. My English is so bad after so many years in this country. Okay? So, a couple other things to notice about the binomial. Okay, you can see that it gives you the expected value. Now, some of the problems on the problem set, they ask for the mean, and some students in class, oh my God, how do we get this? Okay, I told you guys, you have to know that expected value is the same as mean, okay, which is the same as the average, which is the same as mu, okay, that Greek letter, which I don't think I have it on my insert very quickly, so I won't put it here. All right, so Excel gives us the expected value, and it also gives us the variance and standard deviation. All right, so really, I mean, it saves us loads of work. So we have 3 columns. You need to know what the 3 columns are, okay? These exactly, at most, at least, you have to know how to do these problems, okay? You'll find that on the problem set, yes, these will show up, okay? Now, if you weren't able to follow along with that, you'll notice that on the PowerPoint, I have put print screens, okay? So really, there is no excuse for anyone being unable to do this. Okay, I can't make it any clearer. So, what you are supposed to do, the problem set which I gave out several classes ago, I want you to finish that. I'll open it in case anybody is confused and doesn't know what that looks like. Let's see, is this it? No, that is not it. This is it. Okay, so we did that part. Okay, Yes. Okay, and then the last class we did mean, variance, and standard deviation, so we completed that, or you should have completed that. Whether you did or not, that's for you to know. Okay, so here we are, binomial, and here's the horrible, ugly formula, which we would have to use if we didn't have the magic of Megastat. Okay, so I want you to do number 17 until the end. Now, some students in class, when we got to this part, they were confused and said, oh God, how do we do this? Please notice that the Greek letter pi is used to represent the probability of success. Okay, it doesn't mean pi that you learned in geometry. Okay, in statistics, it's used to denote the probability when we're talking about the binomial. So this problem, in a binomial situation, n equals 4, well, n is used for the number of trials. So our number of trials is 4, and our probability of success is 0.25. And then they want us to find these probabilities. Okay, in class, I actually had to do this, so I'll go ahead and do it in this recording as well. Okay, one funny thing about Megastat, which I'm sure all of you will test this to see if it's true or not, if you keep layering the files over on one another, it will eventually freeze. Okay, so you need to close, don't save, and then open a new one. Okay, and that's not really that big of a deal. I think we can all live with that. Okay, so they told us that n was 4 and the probability was 0.25. All right, so I'm going to go to add-ins, Megastat, probability, discrete. Okay, I'm going to hit clear so that it wipes out whatever I was doing before. All right, so my n is 4, my probability is 0.25. So n is 4, probability is 0.25. Of course, I could write 25%. They're the same thing. Okay, and it does all its magic for me. Okay, we want the probability that x equals 2 and the probability that x equals 3. So I told you that an equals, well actually I didn't say this, but if you have basic knowledge of the English language, you should be able to figure this out. Okay, an exactly question, that's what we did in the PowerPoint. Now, exactly really is synonymous with equals, isn't it? X equals 2 means the same as x is exactly 2. All right? So we have x equals 2, x equals 3, and we're supposed to find the probability. Well, the probability that x equals 2 is 0.21094, okay? Because we use the individual column, right? And the probability that x equals 3 is the next probability, 0.04688. All right? So, you do need to complete all of that. Okay? So, problem 17, 18. Okay, you can skip this one, 19A. Okay, that's from the days when I actually had students do this with the formula, when I was much meaner than I am now. Okay, and you don't need to do 20A either. All right? So you can skip those, but you do need to do the rest if you want to be well prepared for the exam. All right, so how many problems are there? Yes, there are 31. Okay, even if you think, now in class some students said, oh, Miss, this is easy, I don't need to do all these. Yes, you do, because when you get to, where is it, the one that everybody has questions about? Yes, number 27 and number 28, okay? Most students are a bit thrown by this. You have to be able to do that. And I will leave it to you to complete that. I probably will put an answer key up on BB Learn later, but not right now.